Hello, everyone, and welcome to our webinar, How to Build a GenAI App with Llama Index. My name is Matt Brown, and I'll be your moderator today. Before we begin, just a few logistical reminders. Today's discussion is being recorded, and you are currently in a listen-only mode. You may submit questions throughout the session using the Q&A functionality in the lower section of your Zoom console. If this is your first time joining a single story event, heads up that we sponsor regular webinars and events demoing data, AI, engineering use cases, and technologies. And actually, the next big thing we're looking forward to is the real-time AI conference on October 17th at the Chase Center in San Francisco. Alex, if you click to the next slide, we can show this. There you go. Today, only Single Story is going to be sponsoring discount codes for this audience only. You can grab your $25 ticket right now. That's usually $199. All you need to do is click this link that's on your screen right now, the bit.ly AI Conference Llama Index discount, or snap a photo of that QR code or a screenshot of that QR code. I will put that link in the chat in a minute. All you need to do is once you arrive at the link, just enter code singlestore-25 during checkout. And I'll put that in the chat as well. So we hope to see you there on October 17th. It will be a really fun AI conference. Okay, now back to today's topic. FYI, we've got some fantastic experts who are going to be joining our Zoom Q&A who have a good grasp of the technologies that are involved. They're ready to answer your questions interactively. We will try to get to as many of the questions today as they come in. And I'll also flag a few for the live Q&A at the end of our session. And one more note, we'd love for you to try today's technology. Anyone who tries out what we're showcasing today will be entered for a chance to win brand new AirPods Pros. All you need to do is click the link that's on your screen, that bit.ly Llama Index webinar raffle, or take a photo of that QR code. And what you'll need to do is just log into that link. Free trial if you're a new user, or an existing account if you're already a customer or already have an ongoing trial. We are going to check all the folks who log into that link right there on your screen, and we will announce a winner of that by the end of today's session. So let me introduce our speakers. First up, we have Alexander Peng, a growth engineer at Single Store, current student at Stanford University, where he's pursuing a major in computer science with a focus on artificial intelligence. He's got a diverse background, including experience at organizations such as Microsoft, Meta, and DevRev. He brings a fresh perspective from the academic realm as well as hands-on experience from these organizations, and we are eager to hear his insights and watch his demo today. And then I'm also excited to introduce Jerry Liu, co-founder and CEO of Llama Index. Jerry has carved an awesome career niche at the crossroads of machine learning, AI research, and startups. He's got an academic background from Princeton University, where he graduated summa cum laude in computer science, and Jerry then subsequently played pivotal roles at Quora and Uber, among others. He is now the brains behind Llama Index, which provides key tools to augment your LLM applications with your data. So welcome to Alex and Jerry. Also, our chief developer evangelist, Madhukar Kumar, has joined the virtual stage. So Madhukar, I believe you have the floor first.
Thanks, Matt. Hey, Alex, I think you are moving ahead in the slides, so it's confusing a couple of people on Q&A. Hi, everyone. My name is Madhukar, and what an exciting day today, because we all just heard that, as we had been expecting, OpenAI just released like a multi-model capabilities to ChatGPT, which means it can now what they call a see and hear, which is it can take text and convert it to audio, and it can also look at images and do things with it. This is one of the key things that we had been also looking forward to, because now you really need a multi-model database in order to do a quick match. So we will be doing another webinar very quickly just on this topic. But today we wanted to talk about Llama Index. Just like LangChain, if you have heard of LangChain, Llama Index is one of those libraries which have become really, really popular if you want to use generative AI. to build generative AI application. And the reason for that is because it gives you an abstraction layer to talk to multiple different data sources, and it gives you the ability to do indexing and a bunch of other really cool features. We have, without stealing the thunder from Alex, we do have a connector with Llama Index, which is what Alex had built. And today we are going to go end-to-end building of a GenAI app using a notebook, of course, and we will show Google Colab today versus using our own notebook, which you have seen several times in the previous webinars. And I'll show you how you can use, just with a few lines of code, how you can provide your context from single store and then be able to create your own GenAI app. So with that, what I'm going to do is I'm going to hand over to Alex, who is going to do the presentation as well as demo. And then Jerry, as soon as he joins, we will do a regular Q&A with him and have him also talk a little bit more about Llama Index and what's in the coming roadmap in the next few months. So with that, Alex, why don't you take it?
Thanks, Madhukar. Yeah, so just so everyone knows, Jerry will be joining us in just a little bit. But before he does, I'd like to just get a little bit into the kind of emerging architecture that we're seeing coming out today for these LLM apps, as I'm sure many of you are interested in. Really, one of the biggest patterns that we've seen in this field today is this trend of retrieval augmented generation. And this is a paradigm and framework that we've seen many Python libraries focused on LLMs try to tackle, LangChain and Llama Index, both of which we'll be working with today in our presentation. And really what retrieval augmented generation is all about is giving LLMs the context they need to not hallucinate. As I'm sure many of you have experienced before, you're using, ChatGPT, you're using Claude, you're using Llama, and it just spits out something totally untrue. It thinks the Golden Gate Bridge is in New York. Maybe that's a bit of a preposterous example, but it kind of gives color to a problem that a lot of LLM users are facing nowadays, which is oftentimes LLMs can't tell the difference between truth and lies. And retrieval augmented generation aims to fix that by putting in the LLM's context or in its chat window facts, grounded, truthful facts that help it craft its answer in a factual way. And what we're interested in today is actually allowing LLMs to ground their answers in your company's proprietary data. And so we're seeing this emerging AI stack architecture, which we can almost liken to a brain, where at the very edge of the architecture, we have our perceptors, our interfacers. So like you can think of it as our five senses and our like hands and feet, the UI, which allows users to interact with the LLM, with ChatGPT, with Claude, with whatever LLM you'd like to use, and also allows the LLM to interact with the world. So by sending out API calls, by interacting with the user through plugins. At the very next layer, we see something like the prefrontal cortex in the brain, which is more focused on reasoning, more focused on taking in some of that signal that we've been getting from like our perceptors and our interfacers and reasoning over them. So these are actually going to be our LLMs. These are going to be our agents. These are going to be some of our connectors. And finally, at the very bottom layer, we have our long-term memory, and that's going to be our contextual data store. And just getting into it a little more deeply, our contextual data is going to be really building up from the bottom up. It's going to be our structured and unstructured data that we feed into our data stores, our data warehouses, which are then governed by data access policies, and then which we at SingleStore have built a layer of disaggregated compute on top of. And all of that allows us to ship these data products and data stories. what are we actually going to store in the long-term memory of these LLMs? There's an emerging kind of term now, which has actually been used in NLP for a while, but which is kind of coming into perception, this term of vectorization, which basically allows LLMs to turn language terms into lists of numbers, which can then be computed over to find the most, for example, the most similar terms to a question or query that you have. And so what are we thinking about when we vectorize? Really, we want to use vectorization when we want and whenever we want to include information into an LLM's context window. So unstructured information like text, images, video, and audio. Generally, we don't want to vectorize sensitive data or data that requires special access, because when we perform a semantic search over a vector database, we are searching over the entire vector database. So that's a bit about vectorization. What is single store? Single store is a database to transact, analyze, and contextualize data in real time. I'm going to speed ahead a little bit here just for the sake of time. Here are some numbers, and statistics, just to give a sense of the impact that single store has already had. Over 3,500 users supported at Uber, 10 millisecond average response time at Tier 1 wealth management. And under the hood, just some more bits and pieces about single store. Really, we're going to be piping data in from our data pipeline into our in-memory rows store. And then for longer term storage, moving information into our local column store, and then for really long-term storage into our cloud object store, so your AWS. Some more key product capabilities of single store, and just to highlight a few. We recently became MongoDB API compatible, and we are also multi-model, which is actually very relevant to what Madhukar was just talking about, and OpenAI's newest announcement today of their multi-model ChatGPT capabilities with voice, image, and audio. We also just added a web-based Jupyter Notebook within single store. And let's just skip over these. Now let's just talk a bit about Llama Index, which Madhukar talked a little bit about, but Llama Index is the reason that we're here today. And Llama Index is one of the fastest emerging libraries being used today for ingesting, indexing, and querying LLM information to assist in that retrieval augmented generation process, so that when we query our LLMs, we're not getting hallucinated answers, but instead we're getting answers that are grounded in truth and grounded in our proprietary data. So without further ado, let's get a little bit into the demo. Okay, so can everybody see this text okay? This notebook, by the way, should be available. I think it's either going to be posted in the chat, or it should be available to you. There's a link on GitHub, which should be posted. And it'll definitely be available to everyone after the webinar. But this is going to be just a really quick high-level overview of some of the strategies that you can use when implementing Llama Index, and just a kind of simple end-to-end demonstration of how to use Llama Index and single store together to kind of marry the benefits of both. So just starting off really quickly here, you're obviously going to need a single store account, some knowledge of Python and SQL databases, and OpenAI API access. So before we even jump into this notebook, actually what you're going to want to do is you're going to want to sign up for single store in order to get your free $600 of credits and to follow along with this tutorial. So if you go to singlestore.com/cloud trial, you should be able to sign up for a free account. And once you're in your free account with $600 of credits, let me just log in here. There we go. You'll be able to start your first cloud group, which will prompt you to kind of select your cloud provider, select your name, select your workspace size, etc. And finally, once your workspace is all set up, you'll want to note down within SingleStore your connection details. So that's going to be available within your workspaces. When you get to your workspace name, you can just click in this little actions column here and get the direct connection details. So you can get like your URL, you can get, if you're opening it for the first time, you'll see your password. And then once you have all of that, you are ready to follow along here. So in this notebook, we're just going to quickly kind of install some of the necessary packages. Here in this demo, we're going to be using Llama Index, a LangChain. Actually, we're not going to be using the Llama Hub package specifically, but the SingleStore connector is actually part of the Llama Hub repository. So if you're interested in seeing the code for that, that's going to be in there. And of course, we're going to install the SingleStore package, set up our OpenAI keys. We're actually going to be using the SingleStore integration with LangChain, though the SingleStore vector store integration with Llama Index is actually coming very soon, so stay tuned for that. But one of the big pluses of using Llama Index actually is that there's a high degree of cross-compatibility with LangChain. So there's a number of different wrappers that you can use to just make sure that data between Llama Index and LangChain is consistent. But if you're already using, that's all to say, if you're already using LangChain, it's very easy to integrate Llama Index into your workflow. So for this demo today, we're actually going to be chatting with the Llama Index, the docs, which, obviously, the base model GPT 3.5 doesn't understand much about. But if we load in the docs using this LangChain document loader, and then we embed it and ingest it into SingleStore with the LangChain SingleStore integration. And then we also use the Llama Index SingleStore reader, which is already out, and you can just install Llama Index and use it here. You can actually start asking questions against, against your set of documents. So one of the really nice abstractions that Llama Index has is when you create a new index. In this case, we're using a list index, which just kind of collates everything together that's been returned from our SingleStore reader, which performs a semantic search over our database. It just collates it all together into an index. When you have that index, you can just initialize it as a query engine, which is another concept in Llama Index. And that query engine can just take in natural text or natural language queries and give you back responses in natural language based on the information inside the index. So if we ask, what is Llama Index? We'll see, okay, Llama Index is a data framework for LLM applications to ingest, structure, and access private or domain-specific data, which ChatGPT 3.5 in its training data has no idea about. Llama Index came out after it was trained. If we ask some more information about data indexes or query engines in Llama Index, we'll see more information which is grounded in factual data, which is going to be our Llama Index docs here. Actually, I'll pull it up just so everyone can see it. And this is what we're going to be basing all of our information on, or all of our answers on. So that's all well and good. We can use, Llama Index to ask natural language questions over our proprietary data and get back answers grounded in our proprietary data. But how about some more advanced tips and tricks? Llama Index also features chat engines, which allow you to turn that list index into something like ChatGPT. Instead of just asking one question and getting a one answer back, you can ask one question, get an answer back, ask a follow-up, get another answer back, and just chat with your data. So here in this example, we're just asking, oh, what's Llama Index? It's an open source library that provides tools and APIs for building and deploying large-scale search and retrieval systems. Oh, what can Llama Index do? Oh, it offers a range of capabilities, data ingestion, indexing, querying. And you can see, you can kind of just keep on going here, though I just interrupted it in this example. Something else that Llama Index can do that's super, super cool, and that calls back into some of the emerging AI architecture that we were talking about earlier. Data agents, which don't just read your proprietary data, but can potentially perform actions, modify, update, delete your proprietary data. Here in this example, we just take that ask Llama Index docs function, which we had earlier, which just kind of gave us kind of basic answers to the questions that we have about the Llama Index docs, and we just give it as a tool to a GPT 3.5 agent, which then decides interactively whether or not to use that tool. If you're, for example, asking a question that's not at all related to Llama Index, there's no need to query the Llama Index docs for information. And so if it determines that there's nothing relevant in the docs to your question, then it won't query it. But in this case, we ask it again, what is Llama Index? It gives us a similar answer to what we got earlier before. And then we can just say, oh, tell me about its capabilities. It has an understanding of what we were talking about earlier. And then it gives us something similar to what we had before as well. Finally, and this is, I believe, and Jerry can correct me if I'm wrong, a relatively kind of new and experimental feature in Llama Index, but you can also fine-tune your embedding models. And so if you'll recall, the embedding model is the model that actually vectorizes your proprietary data into lists of numbers that LLMs can interface with and interact with in order to get the most relevant information to base their answers on. So if you're retrieving documents that are maybe incorrect, maybe not that relevant, then you could be worsening your hallucination problems. And so that's where fine-tuning embeddings comes in. And Llama Index actually provides some very helpful libraries to actually almost totally automate the process of fine-tuning your embeddings. And just to quickly note, this implementation here is not at all a full implementation. It's more pseudocode. But at a high level in Llama Index, you're able to split your data into training and validation data sets, if anyone's familiar with machine learning terminology. Then you use an LLM to generate synthetic question and answer embedding pairs. So you generate a potential question and the relevant document that's going to answer that question, and you're going to generate a bunch of those pairs, which you then feed into the Llama Index fine-tuning library here. You can just in one line run fine-tune engine.fine-tune, and then you have an embedding model, which, hopefully upon evaluation is a significant improvement over your existing embedding models, your OpenAI or open source embedding models, which are just trained on open web text data. So that was a lot to go through. I know I'm almost certain that we have a bunch of questions. And Jerry is actually here with us now, and we'll be going into Q&A. Hey, Jerry, do you want to like introduce yourself really quickly? This is actually the first time that we're meeting.
Hey, yeah. Usually we meet first before the webinar, but this is it's great to be here. Thanks, Alexander, for doing this wonderful notebook and the intro. I was actually following along, and I think it's yeah. I mean, this is great. I think this covers a lot of like Llama Index capabilities. I'm excited for the native single story integration too. I was actually responding to some of the questions just by typing it, but happy to go over it in front of the audience as well.
Yeah, let's actually go into our Q&A now. So
That sounds great, Alex. I've got a list of questions lined up. Go ahead, Madhukar.
Yeah, I was going to say, hey, Jerry, nice to meet you. I think since you joined a little bit late, it'd be great if you can give a little bit of, what you're thinking about the roadmap and kind of use cases that you're seeing. And then maybe it'll also answer a few questions that people have already asked. But just high level, what drove you to build this? What are the typical use cases? What's in your roadmap would be great.
100%. So the high level mission of Llama Index, but by the way, Llama Index is a company. It's a very small startup right now. It's like 5 to 6 people. We incorporated a company back in April, and we started the project back in November, and it used to be called GPT Index. So I started the project more kind of as a passion project when I was hacking around with LLMs, and then kind of grew into an overall toolkit. The overall mission of Llama Index as a tool right now, as an open source framework, and also in the future in terms of like product deliverables, is to really unlock the capabilities of LLMs on top of your private data. So like, I think all the stuff that we're talking about now, like, storing external knowledge in a database, being able to retrieve, synthesize that information, automate workflows, retrieve insights, that's basically some of the core of what we want to do, and we want to do it well. And so to that end, we've really developed different aspects of the framework to focus on kind of like 2 main areas. And a lot of that is around one, being able to ingest and parse your data into, for instance, like a vector database, a structured database, or any other like data storage system. The second piece is tapping into the power of LLMs to interact with these data interfaces. And so, if you think about RAG as a concept, retrieval augmented generation, it's really about how do I, query like a vector database by doing retrieval and then synthesizing the answer. And that's basically what Alex showed with the, you integrate with like the vector database, you retrieve it, and then you use like our list or summary index to actually synthesize the answer. And so kind of orchestrating, providing the right tools to allow any user to go in and interact with these data interfaces is something that we focus a lot on. And so RAG, like this whole concept is something that we've been doing a lot recently, because we do think it's going to be a pretty popular paradigm for at least like a fairly long time. And we want to invest in abstractions to make it robust and easy to set up, but also easy to iterate on and improve. So kind of like looking forward, like what are the things that we're focusing on? A lot of the focus these days, when you talk to users, whether you're like a single developer or you're kind of like at a big company, a lot of pain points are around how do I actually evaluate these models? How do I evaluate the entire system? How do I improve and optimize the performance of these apps, over my data, and kind of educating users on the best set of practices and providing the right tools to help make that happen is something that we're very focused on. And so, you want to define, for instance, like an evaluation benchmark. You want to make sure that you have a robust data pipeline in place, and you want to make sure you have awareness of like different types of retrieval techniques, fine tuning, how to actually plug in fine tuning and RAG together to actually help improve the performance of your system. And so, we are really focusing on trying to make sure that we create not just like new features, but also reliable features that work well. And so, yeah, that's basically kind of like the main focus area. And of course, we're going to continue supporting the open source and also probably building some managed offering as well.
Good stuff. Madhukar, anything you want to cover before we get into audience live Q&A? Madhukar may be on mute. or maybe dropped, but with that, maybe I'll jump into our Q&A here. Okay, so everyone, first of all, we've got way more questions than we could ever answer through the end of this session. We'll do our best. Keep the questions coming. We will try to answer via email afterwards if we don't get to you today. We've also got some folks that are trying to manage the digital Q&A as they come in. So first one I'll give to you, Jerry. This question says, I heard Llama Index can fine-tune only sentence transformer models. Can it also fine-tune OpenAI models and LLMs?
Yeah, so by the way, to be clear, these are like abstractions, so they're not actual services. So we're not in the business of actually providing like a hosted service to actually fine-tune models for you. And so we just kind of work with whatever the provider provides. And so OpenAI does not allow fine-tuning embeddings right now, I think, but they do allow fine-tuning the LLM. So we do have an abstraction for fine-tuning like the 3.5 turbo. OpenAI has fine-tuning endpoints for that. And so we allow you to do that and also easily plug that into your RAG system and also provide some helper tools to make that very easy and seamless within Llama Index. So because the OpenAI embeddings model is black box, you can't fine-tune it directly, but you can fine-tune like an adapter on top of it. So one interesting idea is this idea of like fine-tuning just a transform layer on top of any existing embedding model, right? So if you just take an existing set of like either query or document embeddings, and then you pass it through some transform model, can you actually train this transform model to better learn your own data representation to make it more optimized for retrieval? So we do have something on the query side. So you can actually, learn a transform on your queries to better kind of understand your data latent space. Of course, if you fine tune the document embeddings with this adapter, like anytime you want to fine tune a document embedding, and you change the embedding model, you're going to have to reindex your documents. And so that is generally a challenge you're going to have to run into if you have especially a large number of documents. It's not the worst thing in the world. A lot of people run like batch jobs, basically update their embeddings like once a day or once a week or so. That's just something you have to think about. And so we're actually kind of building some more abstractions in this area, but those are the general thoughts right now.
Good stuff. This next one I'm going to give to you, Alex, first, or you can delegate it if you want, but I know I've seen you on some previous webinars working through this question. So this was from Sebastian. It is a challenge that I've had is trying to split documents. We have 10 years of documents, and that the splitting of the documents is not that intelligent. For example, it doesn't cut the paragraphs, the titles, the tables, the figures of the Word document. So we're trying to figure out our own split strategy, but still querying over several documents has been a challenge. Alex, any thoughts on that?
Actually, I'm curious to hear Jerry's thoughts on this as well. But to give a little bit of my inputs, I think the best answer I can give is that there's no one-size-fits-all solution. It's just going to take a lot of trial and error and a really good evaluation pipeline to make sure that, across the broad categories of your data, if you have 10 years of data, I imagine you have like structured data, unstructured data, everything in between, across all those broad categories of data, that your retrieval performance is, it's relevant and it's actually getting chunks that aren't too big or too small. So in this example, we used just a pretty simple example of just the recursive text splitter, which is just a LangChain abstraction, which I believe recursively chunks data on new line characters or some user specified delimiter. There's that approach. There's, other approaches on just, splitting on every comma or new line character, splitting every set number of characters. There's a number of different approaches you can try here. The unsatisfying answer is that it's not perfect. It's just going to be about trial and error and making sure evaluation is good. Jerry?
Yeah, I mean, basically what Alex said. I think this is still kind of up in the air. I think the overall take I have is if you have that, if you have like a large number of documents, like 10 years worth of documents, I can't imagine how many files that is. I would 100% add some structured annotations to it and see if you can do some initial paths to, do SQL or something to filter out the relevant set. so that you can get back like a more filtered set, and then you can do like semantic search and lookups on top of that. We offer like one query engine we offer is just like a joint like SQL and vector store query engine, which you can try it out or you can build one yourself. It's not that hard. Basically, you just like, assuming you have structured annotations corresponding to your documents, first do some text to SQL use the LLM to generate some SQL query that will like filter out some initial set of documents. And then within that, then like go in and do semantic search. The problem with semantics, like just doing pure top K embedding lookup, is it starts failing once you have like a lot of heterogeneous like documents. Like once you scale to like hundreds, thousands, or even more documents, you're just not really guaranteed to return the right things by embedding lookup. And so, there are just like general things you can try. So the text to SQL as like a filter is one idea. The other is just like have some sort of good re-ranking step. So if you have all these annotations, you can like set your top K to really high, do embedding lookup on like a larger pool of documents, and then within that run a more expensive like re-ranking step to see which ones are more relevant to the query. We have like an entire guide on like different types of production RAG techniques that you can try out. And basically, as Alex said, like you need benchmarks to make sure that this actually works better on your data. And so we've been trying hard to make sure that you have both evaluation of retrieval and synthesis, plus like trying out these different techniques in the loop.
Awesome, good stuff. I'm going to give this one to Akmal, but Akmal, you can feel free to tap multiple folks. I don't know if this is kind of a multi-pronged question, but there's been several questions in the chat about security. How do you ensure security of your data? And I don't know if there's like a single story answer to this, and then also a separate Llama Index answer to this. But Akmal, I figure we've gotten that question in previous webinars, so maybe I'd give you the first pass at it.
Okay, thanks, Matt. Yes, so I understand where this question is coming from. I mean, obviously, this is a concern and an issue for many people, working in enterprise environments where you may be dealing with sensitive data and you want some guarantees or some mechanisms available to control this. I think Eric Hansen covered this wonderfully not so long ago, some webinars back, where he actually looked at, for example, the OpenAI policy about what they do. Yes, they are a third party and they receive the information, but unless you specifically give them the permission to retain the data, they do not. Okay, they evaluate and throw it away. Beyond that, of course, having this running within your own environment, for example, is a good thing. You could do that, have your LLM hosted locally. Or if you are working with one of the big cloud providers, such as AWS, for example, where they're offering Bedrock, you use that as a service within that environment with all the, knobs and whistles that AWS provide, which are actually very extensive. So essentially, you've got a variety of choices that you can take, and it just depends on, what your existing infrastructure or what your existing technologies are or what your existing cloud provider is. And it's good to just assess and look at the options available and then take it from there. I think that's the best answer I can give.
Good stuff. All right, Jerry, I think I'll give this one to you. I don't know if I fully understand it. Maybe you do. Can you offer a comparison between Llama Index and LangChain? Like, how does Llama Index overcome the drawbacks of LangChain?
Okay, well, the first part is, it's a pretty popular question. How to take a stab at it. The second part, I'm actually not sure which drawbacks you're referring to, but I can, anyhow. So the first piece is like, I think Alex showed like, we do integrate with LangChain, so you can have like the same data representations, you can use both, you can use one, it's kind of up to you. LangChain is a very broad framework and they have a bunch of modules and a bunch of different things. And a lot of it's kind of community contributed. So it's kind of like Hugging Face-esque, like you just can pick and choose the things that make sense. I think for us, like we've developed, we kind of like took a lot of care developing like a pretty tailored set of abstractions for building like RAG basically, not just in prototyping phase, but also in production. And so pretty much like all of our our abstractions, like from the basic stuff, like, just the vector store index and like 4 lines of code, you can do QA over your documents, to a lot of the more advanced stuff, like how do you do advanced retrieval? How do you define like graphs over your data? How do you define like metadata and kind of like, integrate that into the rest of your systems? A lot of that's really tailored to help you build kind of more production grade RAG systems. And so I would say like we're more narrowly focused, but also we care a lot about developing like very curated like first party abstractions on this end. And in terms of like integrations, I mean, we have like an integration with like single store on Llama Hub, soon to have like a vector store integration. We have like over like a bunch of other integrations with vector databases, data loaders, that type of stuff. And so in the end, you can kind of pick and choose which document loaders from LangChain or Llama Index you want to use. And so you can use both if you want, but just like from a focus perspective, I'd say we're very focused on just the whole like end-to-end like data process for building LMX.
Good stuff. Akmal, I've got another one for you here. This appeared a couple times. Can we use single stores vector database in local, or do we have to either use AWS, GCP, or Azure? Akmal, you still there?
He's muted.
Forgive me.
All good.
I go quiet so that there's no background noise to disturb you. Sorry about that. You kind of forget. Okay, so yes, with that question, no, you don't need to have it running in the cloud environment. The vector capabilities are built in. So if you download and install it locally, for example, so if you create a cloud account, as part of that, you'll get a license to install up to a 4-node version free of charge in your own environment. And I've often installed a 2-node within a virtual machine that I have running, VMware Fusion, for example. And so you get a license for doing that. Or you can host it in your own sort of bare metal if you like, or if you want to do it within your own environment, you can do that. And the vector capability is built in. It is not unique to the cloud environment. So you can run it locally. That's absolutely fine. There's a Docker image available as well. So if you want to try it there, that's a great way to test it with, no risk, low cost, and just to get some hands-on.
Good stuff.
Oh, just a quick shout out for anyone that's interested in running single store self-hosted. I've had a lot of success using the single store image with this Docker implementation called OrbStack. Super lightweight, super fast, just plugging it in case anyone was interested in running, maybe potentially on their own machine, self-hosted single store instance.
Good stuff. I'll give, there was a couple questions around data formats and multi-model. So, and this might be a multi-part question for multiple people on the virtual stage, but this one is, can we query multi-dimensional data? My challenge is time periods on the columns and names in the rows. And what would be the ideal size of data set that this can query through? I don't know if, Jerry or go ahead.
Yeah,
Go ahead,
I can take a stab at this. I don't actually know if I have like the full answers to this. I think time-based data is very interesting, and I readily admit I don't think we have enough support for that. I do think like maybe this kind of relates to some of the ideas we talked about previously, but I do think in the end, like to have like an efficient or effective query system over like large amounts of data, you're going to want to combine structured querying with both unstructured querying. And so I think like having an interface where you can, let's say, have like a bunch of like time-based data, and you want to select given a user query, select within a time range, and then also have a where clause with like some filters to make sure that you filter out for the relevant set of tags. You probably want to do that as like a first pass, get back a candidate set of documents, and then within those documents, then figure out if you want to continue to do retrieval. And so that's kind of the initial thoughts I have. I think in general, like dealing with like time-based data is pretty tricky, because a lot of times when you deal with this type of data, you have stuff that's just like out of date. And so if you return a bunch of like documents that, have been superseded by other documents that are more recent, how do you actually deal with those types of challenges? And I would actually say, I don't think we figured that out yet.
Just to chime in here as well, Jerry's answer was great, and it actually illustrates, I think, one of the reasons why single store is such a great choice for being both your vector database and your traditional SQL database. Other vector databases are, specialty vector databases. You kind of have to have, your traditional relational, like row store, column store, and then also you have this other environment with another data access policy, where all your vectors live. Doesn't really make a lot of sense to have that when you could just instead have single store and have all your data live in one place. You could use the upcoming integration with Llama Index, where you could just query your structured and unstructured vector data, your vector data and your SQL data, like all from the same database, all with the same governance, all with the same data access policy. So just to add a bit of detail there.
Awesome. Here's another question. Go ahead.
This is like a random comment, which basically had nothing to do with what we just said. But I think one thought I had is like the advantage of having a database that has like some sort of access control baked in is that I think a lot of like enterprise use cases for RAG think about this type of stuff. And so like I think like how do you, if you ask a question and you're like a user and you don't want to act like as an admin, you don't want this person to access like privileged information. How do you do that? And so I think like really a lot of that's going to be at the database and storage layer. And so just like especially with like a RAG system. And so how do you make sure you gate this user's access to the relevant set of data so you can actually like answer questions over it? I think that is one thing to think about if you're trying to like for the audience, if you're trying to like fine tune your own models, is like I think you kind of need to be careful about what you want to fine tune over, because once you actually fine tune this into the weights of the network, it's not really, it's basically impossible to figure out how do you actually gate access to the weights of the network itself. And so that is one thing of like, if you just do RAG, like you can gate access at the storage layer. Anyhow.
Good stuff. So here's another interesting question, and I wish Madhukar was still here, because Madhukar loves to talk about how a next phase of this revolution has to do with agents and our data being able to take action on our behalf, some action in the real world. And so the specific question is does Llama Index make use of agents to help answer the question? And I wonder if Jerry, you can just talk a little bit about agents and either current status or future plans, or talk about that.
Yeah, I think Alex actually showed some part data agent abstractions. I think at Llama Index, we care a lot about this concept of data agents, which are basically knowledge workers capable of advanced reasoning that can plug into existing or on top of existing RAG systems for kind of more advanced like search retrieval or just like general like data workflows. So not only just like reading data and synthesizing over it, but actually acting upon it to take actions. So for instance, being able to send emails, like send calendar invites, that type of stuff. We have data agents. I'll talk about that in just a bit, which are basically just general abstractions. And then we also have a bunch of tools. So if you go to llamahub.ai, it's not just like data loaders, which single store has a data loader, but also just like a bunch of tools that an agent can interact with. And so you can kind of pick and choose the ones that you want to use. Our overall thoughts on agents is that, so with RAG, the LLM has a very limited role. With RAG, it's just like you do retrieval from like a vector database, and then you do synthesis, right? And then when you do synthesis, you just basically call the LLM to take in some existing answers, existing context to synthesize an answer. With agents, you basically use the LLM as a reasoning engine to basically operate over your user query to like basically use the LLM for better reasoning power to better do search retrieval. So you can basically have this as an outer loop. Like given a complex user question, you can use this agent layer to break it down into smaller questions. You can, for instance, kind of like iteratively query a vector database, get back a response, and then do some sort of chain of thought to then ask follow-up questions, and then also do like query planning as well. And so it basically allows you some higher level reasoning primitives. I think the risk of like trying to do too much with agents right now for any given agent is it just goes like off the rails. And so the reason, bigger projects like AutoGPT or like, kind of these AGI projects haven't worked super well yet is because like we're trying to do too much with each agent at once. I think one thing that we found has been effective is that if you're going to build agents with Llama Index or other frameworks, you can, I would try keeping it focused, like have a small set of tools over a subset of data, make sure that works reliably and better than your existing RAG systems before you try to actually kind of go bigger.
Awesome, good stuff. We've got a couple more questions. It looks like we have a few more minutes as well. I want to give one chance to, before I could just keep going through the questions on my list, Alex, Akmal, or Jerry, do you have a favorite question that you've seen in the chat that you really want to make sure that you get answered? Maybe I'll start with Akmal.
At the moment, Matt, I think I'm just trying to answer as many as I can.
No worries.
So, they're very
No worries.
varied and very thought-provoking. Great questions. As always, time is against us. I don't have any particular one that I can draw attention to, Matt, but I'll keep plugging away here.
Good stuff. And what about Alex or Jerry? And also, I'm happy to just keep going through the questions if you don't have anything top of mind.
No, yeah, this works.
Okay. Sounds good. Okay, Jerry, I'll give you this one to you next. Can I use Llama Index with a CSV file? And there was just like a couple questions around like data type. One was like, in what format does Llama Index ingest data sets?
Yeah. So yes, you can use it with a CSV file. I think it's different than maybe the stack that we just talked about and the notebook that Alex showed. I think typically with like structured data, there's a bit of a different stack because when you have something that's already in a very structured format, there's usually a query language for querying that format already. And so usually this is like SQL for like a SQL database, or like you could do like pandas operations operate over like a CSV. So we do support stuff where you can like given a user query, like query an existing pandas data frame or a SQL database. So that's usually the way that you would query structured data. So the whole like RAG pipeline of like, chunking in a bunch of text, splitting it, putting in a vector database, usually you don't do that for kind of like CSVs with mostly structured information. Usually you do that with data with a lot of like unstructured context. So it kind of depends on the type of CSV that you have. Yeah, and if it does have a lot of unstructured data, you could do the thing where you like chunk up each row, like dump it into a vector database and do retrieval, right, on the unstructured text. That is something you can do.
Good stuff. Here's another one. I'll give this to you, Jerry. It's from David. It says, is there anything within Llama Index that helps users who are using an LLM to query their data, single store or other, to help them understand how confident the LLM is in the answer that it's providing? Just a side note from me, I think I saw something about Bard is now providing confidence scales or something to help people understand like hallucinations. But Jerry, I'll let you give your insights.
Oh, interesting. I know Bard has like the after the fact retrieval, but maybe I missed the confidence interval part. I mean, I think in the end, like the simple answer is you could just prompt the model. I don't really know how well that works right now. I feel like there's got to be some work at the model layer to make this actually good, because the prompting approach is you just ask GPT or any LLM like, hey, give me a score from 1 to 5 on how confident this is. The issue with this is that like, it could basically just hallucinate that confidence score. And so there's not really a understanding of how reliable that metric is. And so I think like if you have access to the actual like token probabilities of the model, like not something that OpenAI offers, I think, but like if you actually get access to token level probabilities, you can do some more quantitative metrics on like the confidence, right? Like log loss, like basically the entropy of the response. You can do some more mathematical approach. But I think right now it's, if you just ask the LLM to tell give a judgment of how good the answer is, I wouldn't trust the number too much. One thing that does help though, I think as a general trick, if you're trying to prompt the model, is like give the answer, but then also try giving an explanation. So don't just have it, if you're gonna do this approach where you ask it to output a confidence, don't just output a single number. Actually also say, hey, can you also explain why? And then by explaining why, it ends up actually outputting like a better potential number for it.
Also, to jump in really quickly here, there's so Jerry's answer is really great, and that's actually one of the big pluses, I think, is one of the big pluses that you can see in open source models is that you can potentially get access to those log probabilities or token level probabilities that you can't get from an OpenAI model, though you do have to trade that off against, potentially the open source model you're running is less parameters than like, however many hundreds of billions of parameters the OpenAI model is.
Good stuff. All right, with just a few minutes left, I think Jerry needs to drop, so I will let him go. Thank you so much, Jerry. I'll announce the AirPods winner though as we wrap up, and just a couple more things. But thank you, Jerry. So quick note before thank you. Before I announce that AirPods winner, reminder: today only Single Store is sponsoring discount codes for this audience only. To that real-time AI conference in San Francisco that's on October 17th. I'm putting the link in the chat one more time. You can get that $25 ticket right now. Usually it's $199. All you need to do is click that link that I put in the chat, and remember to enter the code SingleStore-25 during your checkout. Now for the prize announcement. Today's AirPods winner goes to Jaya Prakash, who is the head of data and technology at Disney Streaming based in Connecticut. Congrats and thank you for joining. If that's not you, don't give up. We're going to do one more in the next hour or so. Again, you'll have one more chance to win. Thank you to Alex for the awesome demo. Thank you for Jerry for joining us as well. And thank you for everyone in our audience for joining us today. Have a great rest of your day. Thanks again. Bye-bye.